What if the most terrifying object the James Webb Space Telescope has ever detected is not a planet, not a black hole, and not even a galaxy, but something that should not exist under the known laws of the universe? For decades, humanity has looked into deep space believing that reality, while strange, was still orderly, predictable, and governed by physical laws that we could gradually understand. But now, hidden within Webb's most advanced infrared observations, something has appeared that is forcing scientists to ask a far darker question. What if the universe is not limited to the dimensions we can see? What if what James Webb found is not simply an anomaly in space, but the first visible crack in the structure of reality itself? The object at the center of this mystery was not discovered through ordinary observation alone. It emerged through the combination of two of humanity's most powerful tools: the James Webb Space Telescope, our greatest eye on the cosmos, and advanced quantum analysis capable of detecting hidden mathematical signatures that traditional methods completely overlooked. What those signatures appear to suggest is deeply unsettling. Strange diffraction patterns, distortions in light that refuse to behave according to conventional physics, and repeating structures that closely resemble what some theoretical models predicted might appear if higher dimensions were pressing against our universe from the outside. If that interpretation is correct, this is far more than another astronomical discovery. It could become one of the most revolutionary findings in the history of physics. The story begins in one of the most visually chaotic and fascinating regions ever studied by modern astronomy, the galaxy cluster Abell 2744, often called Pandora's cluster. James Webb turned its infrared instruments toward this distant region with the goal of doing what it does best, looking deeper into the universe than any telescope before it, piercing through cosmic dust, and revealing details hidden from every previous generation of observers. What Webb captured was already extraordinary. The images showed galaxies stretched by gravitational lensing, ancient light that had traveled across unimaginable distances, and a level of detail so remarkable that even experienced astronomers were left in awe. Yet the greatest mystery was not immediately visible. It was hidden within the structure of the light itself. When those observations were processed using advanced quantum analysis, researchers found something that did not fit comfortably within standard models of astrophysics. Around certain galaxies inside the cluster, the light displayed unusual diffraction patterns and distortions in the infrared spectrum that did not match the predictions of conventional physics. This was not simply a blurry artifact or a random imaging glitch that could be dismissed. These were subtle, repeatable discrepancies, the kind that make scientists deeply uncomfortable because they are easy to ignore at first, but become impossible to dismiss once they continue appearing. It was like hearing a strange sound inside a house and realizing it happens at exactly the same time every single night. The more closely these patterns were examined, the less accidental they appeared. That is where the real unease begins. Astronomy is accustomed to surprises. New stars, hidden galaxies, violent collisions, and exotic forms of radiation are all part of exploring the universe. But this anomaly was different. It appeared structured, not terrifying in a cinematic sense, but deeply unsettling from a scientific perspective. It quietly suggested that one of our most fundamental assumptions about reality might be wrong. James Webb had not simply found something distant. It had observed something that seemed to challenge the very geometry of the universe itself. To understand why this object is so disturbing, it helps to step back from the image and consider the theories behind it. For decades, some of the boldest ideas in theoretical physics have proposed that the universe contains more dimensions than the 3 dimensions of space and 1 dimension of time that we directly experience. According to string theory and related models, reality may include additional spatial dimensions curled up so tightly that they remain invisible, hidden within the fabric of the cosmos like tiny folds too small for the naked eye to detect. The mathematics supporting these theories has always been elegant and compelling, but elegant equations alone are not evidence. That is why Webb's anomaly has generated such intense interest. The distortions observed in the light appear strikingly similar to the subtle signatures that some physicists predicted might emerge if higher dimensions were interacting with our observable universe. One of the most intriguing ideas connected to this possibility is that gravity may not be confined in the same way as the other fundamental forces. While electromagnetism and the nuclear forces appear tightly restricted to the dimensions we experience, gravity may be capable of leaking into additional dimensions. Some theories even suggest that this could explain why gravity appears so much weaker than the other fundamental forces. If that concept seems abstract, Imagine a heavy object pressing upward against the underside of a mattress. You may never see the object itself, but you can clearly observe the fabric above it bending, stretching, and deforming. That is the basic idea being explored here. Scientists are not claiming they have directly observed another dimension. Instead, they are asking whether the unusual bending and behavior of light in this region could be the visible consequence of something deeper pressing against our universe from beyond ordinary perception. That possibility transforms this from an interesting scientific anomaly into a profoundly unsettling one. Because if the object James Webb detected is genuinely connected to higher dimensions, then the universe is not simply larger than we imagined. It may be fundamentally different from everything we thought we understood.